This is the real number system, so ordering and classifying numbers. So the real number system is basically a way for us to classify a number based on some of its characteristics. So as you can see here, we have a Venn diagram that's talking about the different number systems. So we know a Venn diagram, typically the ones you will see look like this with two circles, but a Venn diagram will show you that what belongs in what other set. So in this case, we have the set of natural numbers, and the set of natural numbers are just our normal counting numbers, 1, 2, 3, etc. Now, all of those numbers are also considered whole numbers. So we can see over here, whole numbers are starting at 0, and then 1, 2, 3, etc. So if I were going to write, say, the number 4, I would write that here, but notice that's a natural number, and also a whole number, and also an integer, and also a rational. All of these are reals. So everything here is a real. An integer is a positive, negative whole number. So the number 4 is an integer, but also the number -4 would be an integer, or -18 would be an integer. I want you to notice up to this point we haven't had anything with fractions or anything with decimals. The possible exception would be, say I have 20 divided by 5. Well, that answer is 4, and that's a natural number. So you do have to be a little bit careful with some of those. The rational numbers are pretty much any other number. So these are our most common numbers. It's anything that can be written as a fraction. So obviously 4 can be written as a fraction because that's 4 over 1. 0 can be written as a fraction, 0 over 1. -4 is -4 over 1, etc. So anything that is a rational, anything that can be written as a fraction is a rational. So say 3 halves, if I divide 3 by 2, I get 1.5. So that's not an integer, it's not a whole number, it's not a natural, it's a decimal or a fraction. So this includes fractions. It also includes decimals that truncate, which means they stop. Like if I divided this, I would get 1.5. It also includes decimals that would repeat. So say I took 2 divided by 3. In my calculator, I would get 0.6 repeating. So anything that repeats can actually be written as a fraction, and that's why it's considered a rational, because rational is just basically talking about a ratio, and a ratio is a fraction. So that's why they're called rational numbers. The only other category we haven't talked about yet is the irrational numbers. And irrationals are either decimals that don't end or that don't repeat, which means, say I had a number like 1.24796, etc., that just keeps going and there's no pattern to it at all. That would be irrational. If I have, say, the square root of 3, if I take the square root of 3 in my calculator, it's a decimal that just keeps going. However, say I had the square root of 4, that would still be up here because the square root of 4 is 2, because 2 times 2 is 4. So don't just assume because it's got a radical sign that it's going to be irrational. And of course, the most famous irrational number is pi. So pi is also irrational because, as we know, it just keeps going and going and going. So let's take a look at these and place them in the appropriate spot, and we'll talk about what they're classified as. So for my first one, number 5, 5 is a natural number. It's natural because it's a counting number, which means if I were classifying it, I would say it's natural and whole and integer and rational and, of course, real, because everything is going to be real. 2.34, as soon as I see that decimal, I know that it cannot be a natural or a whole or an integer. It's got to be out here. Now notice this decimal stops, and that's why it's rational and not irrational. 1 4/5, that one's pretty easy because it's already a fraction, and rational means it can be written as a fraction. And again, it's not a whole number, or, positive or negative whole number, which means it's not natural, whole, or integer. 0 is a whole number. So remember, whole numbers are all of the natural numbers plus the number 0. So 0 and the counting numbers. So 0 would go right there in whole numbers. To classify, we'd say it's whole, integer, rational, real. Radical 8, if you take radical 8 in your calculator, it's not a pretty number. That number would go here in the irrational numbers. 2/3, this is already written as a fraction, so 2/3 is going to go here in the rational section. Negative radical 16, a lot of people would automatically think it goes into the irrationals, but the square root of 16 is 4, and then that negative on the outside makes it -4, So negative 4 would go in the integers, so I'm going to write negative radical 16 here. 21 over 7, again, don't automatically put it in the rationals, because if I take 21 divided by 7, I get 3, and 3 is a natural whole integer rational real, so I'm going to put 21/7 here. 2.3176 ... means that baby is not going to stop and it's not going to repeat, so it's a non-truncating, non-repeating decimal, which means it's irrational. 3 pi, well, we already talked about pi being irrational, so 3 pi would also be irrational. And then negative 33 over 11, if I divided 33 by 11, I would get 3. Keep that negative out front, so negative 3. Negative 3, not natural because it's negative, not whole because it's negative, but it is a nice number with no decimals or fractions, which means it goes here on the integer section. So that's how we would classify all of those numbers. I wanted to do a little bit of practice with you on how to classify numbers, but I also wanted to review what we learned in that last lesson on how to order numbers from least to greatest. So when we're ordering numbers, it's a really good idea to turn them all sort of into the same format. So it's easiest if you look at decimal equivalents. So negative 6 obviously doesn't need a decimal equivalent. Radical 23, I'm going to use my calculator, put radical sign and then 23, or depending on your calculator, you might put 23 and then hit radical. But you should get radical 23 is about or approximately equal to 4.796. Negative 2/7, if I plug that one into my calculator, that is approximately equal to 0.0286. I've got 3 and I've got 2.3 repeating, and obviously 2.3 repeating just means 2.333, etc. So if I'm going to order these first from least to greatest, I'm going to start with the most negative one, so that would be negative 6. My next value would be my other negative, so the negative 2/7. And now I've got all positive values, so really I'm just comparing the radical 23, which is 4.796, the 3 and the 2.3. And again, least to greatest, I would put 2.3 repeating, and then 3, and then radical 23 would be the greatest of those numbers. So that's the first part, is to be able to order them correctly from least to greatest. Now we're going to look at how do we classify them. So looking at negative 6, I know that negative 6 obviously is a negative, which means it can't be natural and it can't be whole. It can be an integer. So negative 6 is an integer because it's a positive or negative whole number. It's also rational because anything that's an integer is also irrational. It is not irrational because it can't be both rational and irrational. So you're only going to have a check mark in one of these boxes. And of course it's a real because all of these are real numbers. You don't get into imaginary numbers in this course at all. Radical 23. Radical 23 is a radical. We already looked at what the decimal equivalent is. Notice that decimal just kept going. I rounded it off, but it just keeps going. So this one would be irrational and real. So once it's irrational, I know it's none of these other things, so I didn't even have to look. Negative 2/7. Negative 2/7 is written as a fraction, so that means it's rational because it's a fraction, and the only way it would be any of these would be if it was a nice whole number when I divided them, which it is not. So it's rational and it's real. A 3 is a counting number, so that means it's natural, and if it's natural, it's whole, and if it's whole, it's an integer, and if it's an integer, it's rational. And then, of course, everything is real. And 2.3 repeating. Now, this one's one of those tricky ones because it's a decimal, but it's a decimal that does continue to repeat, right? So 2.33333. So if it's a repeating decimal, we're going to write that as a rational because 2.3 repeating is like 2 1/3, which obviously is a fraction. And then a rational is always a real. So the first thing I'm going to do here is I'm going to order these from least to greatest. So for this one, I only have one negative value, so I know that negative 1/2 is going to come first. Now I'm looking for 1 and 0.47 and radical 5 to number these from least to greatest. So the only thing I'm not really sure about is radical 5. So if you put that in your calculator, you get about 2.23, etc. And this one is going to just keep going and not have a pattern. So 0.047 is obviously less than 1, so 47 hundredths. And then I've got 1, and then I've got radical 5, which is about 2.23, etc. So if I'm ordering them, that's my order. Now if I'm looking at their classifications, 1 is a counting number, which means it's natural, whole, integer, rational. So once it's natural, it's all of these. And then of course it's real. 0.47 or 47 hundredths, that can be written as a fraction. The fraction is 47 over 100. So that is rational and real. My next one, radical 5. When I found radical 5 in my calculator, it was 2.23, and then it just kept going and there was no pattern. So that makes it irrational, and of course also real because everything is real. And then negative 1/2. Negative 1/2 is written as a fraction. So a fraction is going to be rational and anything is real.